If you're a researcher or you've ever written a lot of math or engineering, you've probably run into LaTeX. It's a markup language. You write text and comments, you hit compile, and then it produces a clean PDF. It's a gold standard for scientific writing because the output is just beautiful. Equations, references, typography, all of it. At my university, LaTeX is everywhere. Students and professors use it for basically everything. Exams, reports, research papers, and the dominant platform on the web is Overleaf. It's a collaborative LaTeX editor where several people can edit the same documents at the same time. That collaboration part is huge because so much of the work here is done in groups. Well, Overleaf is good, but it has its problems. The big one. On the free plan, you're capped at 2 collaborators per project. So what students actually do is create a shared group email and pass around the password, just so everyone can work together. Think about that. A product limitation is so annoying that it became a habit. On top of that, the AI isn't that great. It can help you drop in a figure, but it can actually edit the document for you. And it asks you to pay right away. There's no meaningful free tier. So, at least in my school, nobody pays for Overleaf because nobody's convinced it's worth it. But here's the thing I want you to notice. These are not random limits. They are just infrastructure decisions. Compile time is CPU cost. The number of collaborators per project is the cost of simultaneous WebSocket connections. And that's exactly where I saw an opportunity. So, I'm Lucas Focasato, a full stack developer with a strong leaning toward infrastructure. When I discovered TipTap, I immediately thought, oh, maybe I could rebuild Overleaf without any of those headaches. So my classmates could actually use it, but with one dream: AI first from day one. I started this project with a friend of mine, and our rule number one is code only ships if we both agree on it. Every decision, cost, infrastructure, architecture, how we organize files and folders, and the repo itself, has to be discussed and defended. We use this project to not repeat the mistakes we've made on past jobs. And here's one of the biggest ones. Cloud and AWS are just fantastic, but cloud with a bad developer experience, where everything depends on the cloud to even run, makes a developer's life miserable. Like a lead I really respect puts it, the development environment is sacred. So, let me show you how I built all of this. Before any fancy infrastructure or backends, version 1 had to beat Overleaf on user experience. And it's live in production right now at claws.studio. You can go try it yourself. A few things I'm proud of. It's clean and looks good, a solid set of hotkeys, a real code editor feel, underlines, brackets, and a little touches that make it feel like home for someone who writes code. It's easy to collaborate, easy to import a project or start a new one. No walls and no ads. Now, let's talk about infrastructure. We started out dreaming big. Redis caching, sessions, multiplayer rooms, and then we cut all of it down to the simplest thing that still solved the problem. We shipped only 3 services: a BFF, a collab server, and a LaTeX compiler. The BFF stands for Project Management, Authentication, and Triggering Compiles. The collab server handles with WebSockets with YJS, where all the magic happened. And the LaTeX compiler is running on AWS Lambda. And here's the first real infrastructure decision. Compiling is a bursty task. Code start isn't a problem here. The user already expects to wait a moment for the PDF. It also needs more CPU and RAM than everything else, because it runs a whole text line. Lambda is perfect for exactly that. It scales on demand, and I don't have to keep an expensive container running 24/7 for something that fires a few times in an hour. Another thing my friend and I went back and forth on a lot was authentication, and I think we nailed it. On the front end, we use BetterAuth with session cookies. But the collab server is much more ephemeral. A user hops in and out of many different projects. So we don't hand the user's whole session. Instead, the API mints a short-lived JWT scoped to a single project, signed with a shared secret. The collab server only has to verify the token. So, the trust boundary between a stateful service and an ephemeral one is solved with a short scoped token, not a shared session. This V1 worked, and by the AWS textbook, it was correct, but it had a problem that only shows up when you look at the bill. Now, let me switch gears for a second. Clause is AI first, but a third-party API for autocomplete costs money per token. And I had an RTX 3060 Ti sitting idle at home ever since I started working full-time. So I decided to turn it into a personal AI server. I wiped the machine and installed Ubuntu Server. I set up a container running Ollama with a local quen model for autocomplete and suggestions. I put Caddy in front for TLS, opened a port on my router, and added dynamic DNS so that ai.clause.studio always points back to my house. And I gave that machine a minimal scoped IAM credential, just enough to update its own Route 53 record and nothing else. So now, my infrastructure has one more component, a PC running in my bedroom. Honestly, hosting and operating my own model, dealing with GPU, DNS, TLS, and the whole network path into production, that alone would have made this project worth it. Okay, back to that cost problem. The load balancer itself is a phenomenal piece of cake, but it costs about $20 a month, no matter what. That was pushing my total bill toward almost $50 a month. And the thing is, Clause is still small, very few concurrent users. At that scale, the fixed cost dominated the bill, without buying me so much. So, we took a decision. Kill the load balancer and ECS, and run everything on a single EC2 box. The containers all run together with Docker Compose, and the monthly cost drops to almost nothing. Now, this is a trade-off. I gave up the load balancer's managed redundancy and accepted a single point of failure. If that EC2 goes down, my apps go down with it. But the box is cattle, not a pet. All of the state lives externally on DynamoDB and S3, and the whole machine is reconstructible with infrastructure as a code, with Terraform. I'm so glad to say that I learned Terraform with this project, and I'm genuinely proud of what was built. I organized it in modules, one module per responsibility. Let me walk you through it. This is the main file, and notice how little it is. Each module is like a function, it takes inputs and returns outputs. For example, DNS module hands back a zone ID, and that same value feeds the app host, the AI server, and email. The composition lives here. The actual resources live inside the modules. Now let's talk about state. State is the heart of Terraform. So here's where it lives, remotely, in an S3 bucket, with locking in DynamoDB. The lock matters. It stops two applies running at the same time and corrupting the state. And each environment, staging and production, gets its own state file, which is why switching environments means reinitializing. And because it's all code, upgrading the architecture was safe. That whole load balancers to EC2 migration I mentioned, I added a new host alongside the old stack, moved resources over, cut the DNS across, and only then I deleted the old module. In small steps, all in Git with no downtime. Now, one more thing my friend and I care a lot about, a real good developer experience. We run LocalStack, an AWS emulator with Docker. You develop 100% offline, no touching the cloud, no cost, no latency, and no fear of breaking production. We also built our own CLI. Honestly, if you've got a project you really care about, build a CLI. With ours, I can pull production stats, check the health of my AI server, drive the local DynamoDB that LocalStack gives me, and run seed scripts. We also have a mock mode, where the frontend runs with no backend at all, swapping every gateway for a mock. Reproducing the cloud locally and having first-class tooling isn't a luxury. That's what keeps a small team fast and the bill small. So, I started from a real user's pain, built the UX first, chose the simplest infra that solved it, hosted my own module, and then refactored for cost with the trade-offs made explicit, all versioned with Terraform with a dev environment I actually love using. There's still a lot left to do. More AI features and eventually paid plans built entirely around AI. And we keep talking to users, taking suggestions, fixing bugs, and there's always work to be done. Thanks for sticking around. I hope this has motivated you, even a little, to take an idea you've been sitting on and actually build it. The learning I've got has already been worth it, and there are always more challenges around the corner. Thanks, and I'll see you out there. Bye bye.